I'm Ben Sigelman. I'm one of the co-founders and the CEO here at Lightstep, and I'm here with Bryan Cantrill, one of the founders and the CTO at Oxide Computing Corporation, and also previously a very fancy, distinguished principal, et cetera, engineer at Sun and other places. He has done some of my favorite work, really in the entire industry, especially around observability in ye olden days of Solaris, and he did, which we'll hopefully talk about. And I'm just happy you're able to join us, Bryan, for this conversation.
Yeah, thanks so much for having me, Ben. It's always good to talk with you.
Totally. So I actually wanted to walk the clock back a long ways. As I've told you, personally, I graduated from the same school that you did, but I don't know, 6 or 8 years after you, and you'd already established yourself as a little bit of a legend, like in the undergrad population, and so a bunch of us were tracking what you were doing when you were at Sun, and you got off to a quick start there, but I'm sure there must have been some period when you didn't know where the bathrooms were and you were just trying to find your way around the building. Like, what was it like just to join that company when you did? Can you talk about what it was, what the scene was at Sun in the '90s when you joined?
Yeah, I mean, and when I joined, I mean, it was kind of a funny time in operating systems development because Unix had been very much left for dead, and indeed, virtually all the OS development had been left for dead. There was this belief that everything was going to run Windows. And I was actually discouraged from seeking out work in industrial OS development. And actually, the reason I ended up at Sun was really that Sun was the only computer company that was doing interesting OS work. I actually pathetically, Data General was going to interview at campus, and I had read The Soul of a New Machine, and which is about Data General in the 70s. Now it's the mid 90s, and even as a 22-year-old, I should have realized that DG's star had long since crashed to Earth, and it was definitely its finest days were behind it. But I looked on the interview schedule, and it was Tom West who himself coming to interview on
Wow.
campus, and I wrote this. I mean, love letter basically to Tom West, describing how I couldn't wait for him to come interview, and I was really looking forward to interview with DG. And Data General canceled. They actually pulled out of, which you're not even like, you're not supposed to do. You're not allowed to. The career services department, basically their only mission in life is to make sure that this can't happen. And I was the only person that had signed up to interview with them, and it was very hard to not take this personally. It's like, clearly, you know, this kid sent me this letter that was like way too forward and creepy and weird, and so we're gonna. There's no way I'm gonna cancel this. I don't think that's actually what happened. I think I mean, they did cancel. I think what probably happened in hindsight was that the company was just in the last stages of collapse, effectively, in '96. Ultimately, DG sold to EMC. EMC, I mean, that became actually very important. The Clarion line came out of DG's storage, became very important. But and that was kind of emblematic for the industry at the time. That the Sun did not interview on campus. The only reason I interviewed at all at Sun is because of connections that we had through my advisor had done some work with Sun in the past. So I basically kicked the door down. I was the youngest person in kernel development by basically a decade,
Hmm.
and they had not done any college hiring really ever. And what I saw was an opportunity. I thought actually SMP Unix was really interesting. Symmetric multiprocessing was really just coming into its own. And I had done some interesting work on SMP operating systems kind of over the previous summers at a company called QNX in Canada, a real-time OS company. So I was really excited for the future of OS development. And honestly, Sun is just the only place where I found that same passion and fervor. So it was very exciting for me personally, but it was definitely generationally weird being so much younger than everybody else. And you'd make I'd make like a Simpsons reference that now would date me as being old, which at the time dated me for being just like hopelessly young. Um, But part of the one of the first things I turned around was like, we need to actually go hire folks straight out of school, because we can actually find people who would be, because nobody else is actually doing interesting OS work. If we really seek out those folks who are drawn to this kind of work, we can pull together uniquely talented people. And one of the things that actually I remember vividly being in Jeff Bonwick's office. Jeff Bonwick was the engineer who I'd really I had gone in there to work with. And Jeff would later go on to invent ZFS and do a bunch of other interesting work. But Jeff at the time had done tons and tons of interesting kernel work, invented the slab allocator, done a bunch of other things. I remember telling Jeff that, like, if we aggressively recruit, we can build something really unique here. We can build a kind of a Xerox PARC for OS development, and I feel I feel that was not wrong. I think that you look at the work that was done in the early 2000s in DTrace and Zones and ZFS and the fault management architecture and the service management facility and all of these, and least priv and fire engine, and there were a lot of OS technologies that proved to be very ahead of their time. And maybe the Xerox PARC line was prophetic in more ways than one,
Yeah.
because obviously the company didn't ultimately survive it, but it was a really great time.
So I guess you said that Jeff was the person who took you under their wing originally when you. I mean, he seems like he was your champion almost to come and join the kernel group. Who was he your main mentor when you started there? And were there any particular lessons that, like meta lessons that he shared with you that have served you well in your career?
I'm not sure if there are lessons that have served me well. I mean, Jeff was a very good fit for me in a lot of ways. Very energetic, terrific technologist, and also just a very strong believer in making the right thing happen. Jeff had a great line that I think anyone should apply to any workplace, which is, when you can't make the right thing happen, it's time to leave. I mean, and it can be hard to make the right thing happen. I mean, you and I both work for large companies. Large companies can be operate across purposes, and they can be political, and you can have. But if you and so you may have to endure a lot of things to make the right thing happen. But if you literally cannot make the right thing happen, if the company is doing the wrong thing despite your tireless effort, it's probably time to leave. And that is actually the metric that I've used over my career. And as a result, I mean, I haven't left that many times. I haven't worked for that many companies. But I think that there was a sense of really working hard to make that right thing happen, and to not really accept compromises in that regard. And on the one hand, I think that maybe that made me more strident at a time when stridency probably shouldn't have been encouraged. But the older I get, I think the more I appreciate that. That on the one hand, and it was not devoid of nuance. I think it was not. It was still amenable to some measure of compromise, but being principled in one's engineering, and having an idea of what the right thing is, capital R, capital T, is really, really important. And then the other way that I think that more the kind of boots on ground, the way that Bonwick influenced me is he was very fond of something that we called big theory statements in the code, where he would write really this great expository writing in the code explaining how something worked. And that was very influential for me personally. I had never really seen code comments be elevated to that kind of an art form. And I mean, if you go into certainly if you go into the DTrace source, but if you go into the code that I've written since, you will see that influence very clearly. And then the thing that's been fun for me is then the engineers that I've brought up over the years have inherited that same kind of zeitgeist. And so there's almost an entire school of engineering that is really due to Jeff's influence in that regard. And I think that because the challenge is to really write something down and describe it thoroughly means that you yourself understand it. I mean, you and I both understand how hard it is. It's much harder to describe how something works than it is in some ways to get it working. Because when you go to describe how it works, you immediately go to the edge conditions and so on. And you may decide or may discover that, like, actually, this thing doesn't work as well as it should, or I don't understand why this is working in certain regards. And so that effort of actually writing it down forces you to really intellectually cover all of your bases in a way that you can communicate it to somebody who is new to the code, which is another thing actually that another kind of influence that Jeff had on me. Something that he believed very strongly is, this kind of Richard Feynman like belief that we should be able to explain these systems, and if we can't explain how something works, we probably don't understand it ourselves. Which is something that I really fervently believe, and I've taken with me in my engineering. As Jeff was fond of saying, a quote that I wrote down of his: "It's very complicated to make things simple." And I'm just my brain has a hard time absorbing massive amounts of complexity, and when I see things that are incredibly complicated, I definitely think, God, isn't there a simpler way to do it? Maybe a harder way, but isn't there a simpler way to do it? So Jeff had a lot of influence on me in many dimensions as an engineer.
Yeah, that's wonderful to hear. I mean, I think there's a lot of humility that's required to take the thing that you've created and explain it in simple terms. There's a tendency in certain circles where complexity is prized. Academia, where you're not encouraged to make things simple, and I
Right.
think it requires a humility in addition to a lot of intelligence and a pedagogical sense to make things like the many systems and even things like the slab allocator. It could be, you could make that sound really complicated, or you can make it sound digestible, and he had the humility to make it digestible, right? um,
Yeah, no, I think you're right, and I think you're right about that because I think there's a sense of like I'm going to elevate you to where I am. I'm not pulling the ladder up behind me. I'm not holding on to my knowledge because I'm afraid of you having it. To the contrary, I want you to have the same understanding that I have. And there is a kind of a humility and a kind of an intellectual generosity and a confidence that, frankly, that comes from that. That I'm not so afraid of my own personal demons that I can't let you have the same understanding that I have of the system. And I think you're right. I think that sometimes people hold on to complexity and they don't want you to understand it because then what's their service? And that's a totally misguided view of technology.
yeah. So you mentioned DTrace. I certainly want to talk about that a little bit. Before I ask you any of the meaty questions, I'm just curious if you'll do a better job than I would, just to give the quick elevator pitch, like what is it, what's it for, that sort of thing.
So DTrace is a facility developed, I mean, almost 20 years ago now, for the dynamic instrumentation of production systems. So DTrace came out of a very simple problem that I had, and I know that you had, albeit at a larger scale, which is I've got a complicated system that's doing something. What the hell is it doing? Why is the system not operating as well as we think it should be? It's not crashing, it's operating, but we want it to be operating much more efficiently. And what is the software doing? What's happening? And I've always kind of, I think it kind of goes to the same desire to understand these systems and to kind of cut through that complexity. And what is the system actually doing? Let's turn the light on the system. And the problem is that in a running system that is executing, hundreds of millions, billions of instructions per second, how do you figure out what it's doing? And historically, the way we have not had good ways of doing that historically. Certainly, the state of the art when DTrace came along was people would modify systems to more or less have kind of printf style debugging, the kind of the printf, we got here kind of debugging, or they would stop the system. And you would stop the system in a debugger, and kind of understand where the state was when you stopped it. But of course, when you've stopped a system, it's no longer running. So there's a whole bunch of queries that you can no longer answer. And to stop an operating system kernel, it very much perturbs the system. And it can be useful under certain scenarios for sure, but there are lots of other pathologies for which stopping the system actually it operates the system at cross purposes to what you're trying to actually debug. So that's the questions that we were seeking to answer is what is the system actually doing? And the observation was that we need to dynamically change what the system is doing to actually give us data, but only when we're asking the question. That when we're not asking the question, we want to go back to a completely optimized system. And I think that emphasis of actually having an optimized system that we would then dynamically instrument, I think, such as there's a novelty to DTrace, I think it's that. I think that so much of the debugging literature prior to that was really focused on debugging systems in development as opposed to actually examining systems in production. And we had a whole, I think, a set of principles about the way we would do that. Because obviously, if you're going to instrument a system in production, it needs to be done completely safely. And it needs to be done in a way that can't errantly panic the system. Or because we knew that when you're talking about a production system, you don't have any strikes to give in terms of if you run a tool and the system dies as a result, you will never be allowed to run that tool again. And especially in that era when the systems were becoming larger and larger and larger and larger, and you had a system where an entire business would be operating on a single system. I mean, eBay famously in 1999, there was a crash of a single E10K that had eBay dark for 22 hours. Now, obviously, we don't run our system. I mean, which is its own horrifying story. We obviously don't run our systems that way anymore, but the idea that kind of every system is sacred and you can't panic a system, and you shouldn't be able to destroy a system by debugging it was a very important constraint we imposed on ourselves for DTrace.
Yeah, first do no harm.
First do no harm. That's right.
Right. So when was there a moment for you? For me, there was actually with Dapper, which I think of as frankly a lesser system than DTrace, but
Oh,
that's not
stop.
the point of this. No, I mean it, just every word of it, especially. But anyway, that's not the point. Starting over, was there a moment for you with DTrace when you realized this was actually going to work? Because for me, there was a
Yeah.
period of like, oh, I don't actually know if this is going to work or not, but let's find out. But then it was like, oh, this actually has legs. I'm just curious for you if you had a similar experience.
Yeah, I mean, and as with many of these things, it comes in fits and starts, right? So you will have there's that kind of moment where like the initial idea has legs, I definitely remember that moment where we were, and what we had basically asked for was 6 months to prove out some of these ideas. And it had taken us actually a long time to buy that 6 months of 20% time in the Google parlance, but it's like we need to be able to go focus on this really speculative work for 6 months. And the problem was that there were too many other crises to deal with before it took us such a long time. And it wasn't actually, I mean, I definitely remember vividly because it was right after 9/11 when we actually had the opportunity to really, I mean, it wasn't because of 9/11, but we finally had the opportunity to really go off for that 6 month period. And it was only maybe 2 months into that when we could dynamically instrument the entire kernel, and you could turn on all this instrumentation around function boundaries that we hadn't had before. And I remember being able to like instrument the NIC driver while the system was running and see the entire flow of NIC functions. And it was like, okay, this is actually pretty neat. So you could see like the initial idea had legs then. I think that then there was an extended period of like, is this thing ever going to work? Because I would make a habit of whenever I wanted to debug a problem, I would go to use DTrace to debug it. And for years, in using DTrace to debug a problem, I would find the problem, and then I would also find a bug in DTrace. And I just remember having like, am I ever going to go to use DTrace and not also find a bug in DTrace when I am? And that period felt like it went on forever. In hindsight, I think it went on for no more than maybe 2 years. and we would fix both issues, but slowly DTrace got to the point where it got and the failure modes of DTrace, to be clear, the bugs were never that the system would panic. The bugs were much more in the DTrace itself would not operate properly, so they would not kind of violate our principles, but it was like these kind of the things that needed to be fixed within DTrace. There was a moment where I kind of realized that this was large, because there's the moment where you realize like this is going to work for me, and then there's a moment, and I imagine you have the same thing with Dapper, where you're like, okay, I'm on to something that's actually kind of larger than myself here. And I think that there were a couple of moments there. One, as we began to, I honestly, I viewed DTrace as really a kernel instrumentation facility.
Yeah.
When Adam Leventhal joined the two of us and extended that up into user level processes and being able to dynamically instrument all the processes on the box, there was a light that went on that realized, like, wait a minute, like I've been focusing on all this pathological behavior in the kernel. I mean, userland there are tons of pathologies in userland, and you begin to realize that misbehavior high up in the stack can induce this hurricane of work down stack. And there was one particular problem that we actually talk about in the original Usemix paper, where a Sunray server had just absolutely abysmal performance. Sunray was actually one of the great. Do you know what Sunray is? Have you ever seen Sunray?
No, I totally know what Sunray is, because when I interviewed at Sun, and they rejected me, by the way, wisely. They like had these little ID cards, and they scanned into new computer, and then their workstation just popped up on that screen, which you know it felt completely magical at the time.
It felt completely magical. It really
Yeah.
did. So it was a smart card, and you plug it into a dumb terminal, and basically the terminal was only a frame buffer. Your entire X session was living on the server, and so as a result, you could pull it out of the dumb terminal, and you could move to. And you probably saw the same demo that I saw. People would get videos playing and all this other things going on, and they would pull their smart card out and walk across the room and pop it up in another one in their session, and it felt magical. You're right. I mean, it felt like I just remember being
Especially in like 1999 or whenever they started working on that, it
that's
was
right.
ridiculous.
It just felt otherworldly. And the Sun, ultimately, Sunray did not succeed to its kind of initial vision, and we can talk about that for a lot of interesting reasons. But Sun moved itself onto Sunrays, and so there were Sunray servers inside of Sun, and there was one in particular that had a ton of people hanging on it. That was a disaster. The thing was just slow as hell, and they could not figure out why. And they wanted me to look at it. And at this point, DTrace was far enough along that I was definitely done looking at systems that didn't have DTrace on them. I mean, there was absolutely no way I was going to look at a system that didn't have DTrace on it. But this was after I was over kind of crossed that Rubicon for myself. But it was before we had integrated DTrace into the operating system. So DTrace only existed in this kind of prototype form, which we had kind of an internal alpha that anyone could run, but it would require you changing your operating system from the supported operating system to the one that we had that was built with DTrace. And I explained it to these guys that, like, look, I'd love to look at this, but there's no way I'm going to look at this because it's not running DTrace, and I'm just like, I've made the life decision that I don't look at systems that don't have DTrace on them. And they kind of like disappear. And they come back a couple days later and they're like, okay, we've got DTrace running on it. Like, now will you look at it? And I'm like, wait a minute, that doesn't make any sense. But this is actually running in production. Like, yeah, it's running in production. I'm like, okay, so you took our development bits and we're now running them in production. I'm like, okay, now I feel a moral obligation to look at this. And what I discovered remarkably quickly by just really starting at the bottom of the system, which was just being absolutely abused. I mean, the system is being absolutely mauled. And what was actually happening is there was a huge amount of VM traffic going on, VM mappings being torn down and replaced. And what was actually doing that was the creation and destruction of graphics contexts in X servers. GC is something that GC not in the garbage collection sense, but the graphics context sense, is something you kind of create once when you start your X application. And that's the thing that you use to do all. Well, these things were coming and going all the time. What was doing it, as it turns out, it was a dumb application. And the dumb application was a stock ticker applet and GTIC2 applet 2, which was creating and destroying a graphics context whenever it wanted to draw anything, which is like the number one sin in X server performance. And so it was doing it 100 times a second. And there were only 6 of these running. There were 6 stock ticker. So there were 6 employees who were running a stock ticker applet. Now, as an aside, I'm a child, you are as well, a child of the dot-com bust. I've got no idea why anyone wants to know the value of their Sun stock in 2001, 2002. You'd have to be a masochist that is like fantasizing about some massive loss carry forward because we were already been mauled by the public markets. But those 6 instances were mauling this machine. And when we stopped them, it was as if a hurricane had blown over. And all of a sudden the system was almost nearly idle. Even though it had hundreds of users on it. And it was just this eye-opening moment of like you had this single application that someone had not really thought very much about because like why would you? It's a stock ticker applet, who cares? And only the small number of instances of it were causing this absolute hurricane of work down stack. And it showed one that the peril, and both the power and the peril of those abstractions in terms of when you're at that top layer, you can create this huge amount of work. It also showed to me that it is the aspects of the system that you think about least that often have the greatest performance pathologies. The part of the system that you've thought about the most is almost the least likely to have performance pathologies because you thought about it the most. It's the stuff that you haven't thought about. It's the monitoring script. It's the thing that, it's some bash script that is running every 10 milliseconds instead of every 10 minutes as it was designed, or whatever it is, right? And so it was that kind of moment where you realize like, wow, this thing is a lot bigger than I am. And we've actually stumbled onto something much larger than ourselves, which is the software broadly is operating out of sight. It's not observable. And because it's not observable, we have these war crimes of performance being committed that we can't actually see. And then you realize like, okay, turning on the spotlight on this stuff is going to be a big deal. And hopefully it's going to inspire others to do the same because there's just a lot to be found in suboptimal software.
Absolutely. I mean, we some very parallel things that we discovered when we were when we initially rolled out Dapper and a few other tools inside Google. We were able to achieve significant wins in terms of the performance of Google's backend services and things that would be measured in like 20-25% improvements in latency for things that had been tuned really carefully for many years, which felt like a big deal. And then
Totally.
we finally, after a lot, we being not me, we being Google, someone had the bright idea to actually do a principled study of what was end user perceived latency from the browser all the way, and then connect that into the server side tracing. And found out that for the majority of human beings, which is to say not Americans, like almost all of the latency was between their machine and Google's data center. And it led to a complete redo of the way they even thought about data centers. They basically created their own data centers that were just a point of presence that then had Google owned fiber from that data center to the real data center that had actual compute in it, just to cut out that latency. But no one had ever really asked the question and realized that we were kind of saving cents in the dollar when like 78-80% of the latency was basically just like kind of lousy ISPs in other parts of the world. And,
Right.
and no one ever thought to ask. And another thing with DTrace, I always think of that shouting in the data centers video. For people who
Oh,
haven't seen
yeah.
it, you should look it up. But it's basically one of Brian's esteemed colleagues is in an extremely noisy data center, which is to say all data centers. And there's this rack of disks basically. And then he literally shouts at the top of his voice at the disk like a death metal scream. And then at the same time, they've instrumented with DTrace to show that there's this huge spike in errors and latency on those disks because they are vibrating so much from the shouting. And it's a pretty cool demo of DTrace operating in real time and revealing very plainly revealing a pattern of failure in a physical disk.
Yeah.
And is that a fair summary? Like
Yeah, it's a fair summary. Yeah, that
and
story.
how did you
And
how did
that
that
was a
happen?
lot.
Like what happened did someone shout and
Right. How did we
realized that, like,
possibly
how
end
did
up
that?
there?
Yeah.
Yeah, so we actually, it was funny how we ended up there. So we were a group inside of Sun, Fishworks, which very much had modeled ourselves on Skunkworks at Lockheed, where we wanted to go develop a new product, but we wanted to do it while still working at Sun. So we were in our own real estate, actually in San Francisco, above the Walgreens at First and Mission, kind of class B, true class B real estate, because with the bus terminal used to be there, right? So the bus terminal is kind of where all dreams are dying, basically across the street, where people are kind of flopping out onto San Francisco. But that's where that machine was in an old MCI WorldCom data center that was in there, and we're developing the storage product. We had a JBOD, just a bunch of disks. And in that JBOD, we had there was one spindle that was seeing these IO latency outliers, and we couldn't understand what was causing them. We couldn't. We were trying to understand, like, we're going through the SAS expander, trying to understand, because we kept thinking like this is a software issue, or maybe that there's bad media here. We can't understand what's causing this one disk to have these latency outliers. And we're about to go to lunch, and the engineer who I'm working on this with says, like, well, why don't we go look at the machine? And I'm like, okay. I mean, the machine is next door. I'm like, you think we're gonna find like a raccoon or something? Like, why are we gonna, like, what are we gonna, I mean, fine, let's go. Yeah, sure, let's go look at it. We're on our way to lunch. Might as well. I mean, I didn't have a better idea. So we went to look at the JBot, and we pulled out the sled that had the disk. And as we pull it out, I mean, I just remember like hearing myself kind of inhale and gasp as we realized that the screws in the sled were all gone. So the screws had all worked themselves out. And the disc had been vibrating. And so it's like, wow, this is really interesting. And it showed like what Vibe could do to an actual disk. And we wanted to go like reproduce this, and to kind of to show what we had done and how we discovered this. And Brendan Gregg had the idea of I'm going to actually see if I can generate this with sound. So he was writing this like Python script to generate this like range of tones or whatever. And like, all right, fine. So
Like,
he's
just yell at it, dude.
objecting.
Yeah.
What's that?
So just yell at it.
Yeah, well,
Skip the Python.
so this is like, and this is between the Christmas and New Year's in 2008. And I always loved that week because you get though that week feels like very relaxing and very productive. I always ended up spending like a lot of time with my family and a lot of time working that week. It's very nice, right? Because you don't have any meetings or no other distractions. And so Brendan and I are both in the office working. We're the only ones in the office. And Brendan has gone off to the data center to like play this Python script to play tones at a disk drive to see if he can get it to do anything. And Brendan comes running in and says, "You have to see this," and goes running out. And Brendan is just the kind of guy that if Brendan is running, you run in the same direction that Brendan is running. Like it just does not happen often enough. You'd be like, all right, like whatever. Like I don't even know if I'm running to something or from something. Literally, we go into the data center and he screams at the disks, and all of a sudden, we see all the latency numbers go wild. And he does it again. I'm like, all right, we got to video this. So the video that you've seen is me grabbing the video camera, and I'm only seeing it basically for the second time, which is why you can hear us both laughing when he's doing it, because we're so kind of delighted and surprised by the fact this is happening. And we cut the video and uploaded it to YouTube, which was very new at the time. I think YouTube had only been around for a couple of years. I mean, it had been, and I'm thinking like this will get like 1,000 views or something on YouTube, and whatever people will see it. That video I think has got well over 1 million views at this point. It became the most viewed material ever produced by Sun that was not a Super Bowl ad. Sun did 2 Super Bowl ads that were very ill-advised.
Yeah.
And so we were talking to the marketing, because at one point, this is Sun. One of the great things about Sun was a company where it was you definitely asked for forgiveness rather than permission. So we definitely did. I mean, it didn't even cross my mind to like ask anyone before we uploaded this thing to YouTube. And later we were talking to some of the Sun marketing folks, and we were asking them about the video, and they're like, "Oh no, we've definitely seen the video." And we're like, "Yeah, sorry. Hopefully we didn't hopefully we didn't ruffle any feathers." Like, no, it's fine. It's great. The only thing we do wish you had said Sun Microsystems in there. I'm like, did we forget to mention the company? And we did. We forgot to mention the company. So sorry, Sun, Ghost of Sun. We forgot to mention the company. But it's because we didn't think we were making an ad for 1 million people. We thought
You
we
could
were.
be making money for Oracle at this point. Nothing, no wrong done.
That's right. Exactly. I know. That's right. We're just. Yeah, God, now you got me derailed. But so anyway, that was a video. It was a lot of fun. It's actually been used by a lot of people. I know it's been used to highlight the effect that Vibe can have on infrastructure, and what's called a run out. So the run out is being induced as the head is slipping off the platter effectively, or slipping out of its track actually. And I know people have used it to show and I know there are startups that have used it to highlight the need to reduce Vibe in the data center and so on. But it definitely showed a real issue, and it was certainly a lot of fun. YouTube was convinced for a while that I was some like proto YouTuber, and kept like offering me like it wanted me to participate in its like revenue sharing plan or whatever, and I'm just like, I'm like a one trick pony. I don't have anything. I've got nothing else in the quiver. Like, this is it. We're one and done on the viral videos. But it
That's
was
really
fun.
funny. It reminds when I saw it, the thing it reminded me of was I think this is in like 2004, 2005, and we were looking at global time series database stuff from Google, and one of the things that we measured were error correcting code violations in
Yeah.
CPU chips. Okay, so all these chips have they do have ECC, and so that they can detect arithmetic errors, which of course aren't supposed to happen, but they do. And then every once in a while, like for reasons that no one really understood, there were like not local but global spikes in ECC violations, and they're very pronounced. It was like way obvious that something had happened, and
Huh.
we were all just like, "There's some kind of bug in the TSDB. Like, how could this possibly happen?"
Yeah.
And we searched and searched. To
Was
make
it
a
solar
long
flares?
story short, what's that?
Is that solar flares?
Yes, that kudos to you for knowing that, by the way. That's amazing. It was basically sunspots that
Yeah,
like
interesting.
these solar flares would happen, and someone made the joke that Google had built like the world's most expensive solar flare
Solar flare
detector.
detector. Yeah.
Yeah, but
No,
it
that's
was pretty
interesting.
compelling.
Um, I would say that is the exception rather than the rule, in that whenever people see any kind of EC error, correctable or not, the first thing people go to is high energy particles, and it's basically never high energy particles. But that's the exception. I mean, just so that when you got that kind of geosynchron, when you're seeing multiple geos have the same incident at the same time, that's interesting. Yeah, we had an absolute at Sun a pandemic of eCache parity errors that. And in understanding where those were coming from, there were many different underlying causes. Virtually none of them were from high energy particles. And the key is, are you seeing a higher incidence rate in Denver than you are at sea level? Because Denver is actually a mile high, and especially at like Los Alamos, which is even higher.
Hmm.
If you are not seeing an elevated incidence, it's almost certainly not coming from space. It's coming from something else. And in our case, that was coming from a bunch of different places, and learned, not least the radioactive boron that had been, there's an impurity in our SRAM manufacturer's process, and there was radioactive boron in the SRAM cells, which is bad.
Wow, interesting. So I've got two more questions for you. So DTrace, we were talking about that earlier. I'm a big fan, as are many other people. And then you were talking about Adam Leventhal's work to push it into user space. The pivot tracing paper that won best paper, I think in 2015, in some ways allows the thing about DTrace that's so cool is how it's programmable it is. You can write um, these programs that look to a layperson a little bit like an awk script or something, except it's much more powerful and it runs on the entire machine. Pivot tracing put some constraints on it, but allowed you to do something kind of similar, but not as powerful at the level of a distributed system, and that you could actually ask questions and it would really run a program on top of the system.
Yeah.
Um, have you ever, I mean, I'm sure you've thought about it. Why isn't something like dtrace running across truly distributed systems? Like, I mean, there are lots of potential answers, but what's preventing that from happening? It seems like it would be so powerful to be able to really bridge all those gaps.
Yeah, it would be, and we have in kind of fits and starts over the years, and certainly when at Joyent, where prior to co-founding Oxide, I was at Joyent, cloud. We were a cloud computing company, and we would instrument the cloud with some regularity, usually to usually out of some measure of desperation, because there were a couple of over the years, some of our nastiest problems required instrumenting the entire cloud to be able to kind of to figure out. I mean, there is definitely there's a lot to be built there. I mean, because you need basically a really coherent command and control. But I don't know what the why to answer your question. I mean, I think that people have done a lot of what you would be able to do with that. People have done via Xtrace and Dapper. I mean, there are kind of other systems where people have found ways to instrument a distributed system and get views into it, which is great. It's they're not exactly they're not giving you the same kind of view that a dtrace would give you necessarily, but it's also a much harder problem because you've got that whole that whole cap theorem is a real pain in the ass when it comes to actually making sense of a distributed system. So I think that there are I think a lot of reasons why we don't have exactly that, but I think it's been fun for me to see anyway that people have a real emphasis now on the observability of software, which has been a lot of fun. I mean, I think that's when I first started talking about software observability, it didn't feel like anyone else was talking about it. Maybe they were, but it definitely didn't feel that way. And now it really feels like it's a topic that people really care about, and are really seeking to understand their software. So I think there's more emphasis on it than ever before, for sure.
Yeah. And then I just wanted to ask you about Oxide. I mean, I think it's a fascinating company, a truly fascinating company. Did you want to give the quick pitch for what you guys are up to and what problem you're solving?
Yeah, so I mean, the problem we're solving is kind of the problem I've been trying to solve my entire career, which is how do you make reliable server side computing systems? And the part of the challenge we've had in the last decade or so is with the rise of the hyperscalers. The world has diverged. And if you look at the hardware infrastructure that you have at a Google or a Facebook or an Amazon or a Microsoft, it's in very stark contrast to what the rest of the world is allowed to buy. And it was really frustrating for us speaking at Joyent, where we were trying to put together a industrial strength elastic cloud on Dell and Supermicro and so on. And you're trying to build on quicksand. I mean, they're personal computers. They're not fit for purpose. And one of my co-founders, Jess Frizzell, talks about Google having infrastructure privilege, and I do think that there's a real sense where at least Facebook had kind of the Dell and HPE and kind of kicked them out. Google just never did. Google never really. There's a level at which Google never really internalized how bad it is for everybody else. I mean, not clearly they do. At some level they do know, but. If you look at the warehouse size computer, or you look at what Facebook has done with OCP, they're great designs, but they're not available for folks that want to run on premises. And our big belief is that other people deserve that kind of infrastructure. That not all compute is going to be public cloud compute, that there are good reasons to run on premises. And if you are stuck running on prem, right now you feel as if you're being actually worse than ignored by the market. The market actively thinks you're a dummy. They think you haven't heard of the cloud. And it's really kind of insulting to those people that are running on prem for good reasons, because they're trying to build elastic infrastructure on prem and they do not have the tools to do it. So, that had been our frustration. And we really realized that we needed to integrate software and hardware together, and really trying to undo. I mean, one of the challenges we have had is that when x86 bested every other microprocessor, it wasn't just x86 that won, it was the PC that won as well. And that brought with it an ecosystem that is really not amenable to server side computing. And what we're really trying to do is break that and shed the PC heritage, get rid of things like the baseboard management controller, the BMC, which is the computer within the computer. That if you rip off a motherboard, you see that this other CPU sitting there that sits on the brainstem of your machine, hanging out over the internet, running some ancient Linux that is vulnerable to all sorts of remote exploits. So really trying to take a clean sheet of paper, rack scale design, integrated hardware and software, and then deliver that to those folks that are running on prem. So it's a little ambitious. As one of our Adam, you mentioned that Adam actually is now working at Oxide. Adam is had, I think, the original quip. It's like, I think this is 8 startups in one startup, and it basically is. We basically have 8 different startups. It's challenging, and it's audacious at some level, but it's also, and I think probably like you at Lightstep, it's like, we should want to solve the problem that we want to see solved in the world, no matter how audacious that is. That it's so much more important to have that drive than anything else. And I mean, because I feel like you and I are pretty similar in this regard. It's like you and I are just like not kind of like triangulators to figure out like what is the missing like gap in the market. And okay, the market needs a 5th scooter company. Like, okay, I'm gonna go. It's like that's just not who I am. I don't think it's who you are. It's like I want to solve the problems that I want to see solved in the world. And honestly, if someone else were solving the same problem, I'd go work for them. It's not that doing it as our own thing. I would have been totally happy to have discovered that actually Dell got it all figured out and it was just great. But that's not what we discovered when Samsung bought Joyent, and we did a massive build out on Dell and Supermicro and discovered that it was actually every bit as bad as it had been over the last 15 years. So that's the swing we're taking.
Incredibly exciting. I
Yeah,
hope
it's
all
exciting.
8 of your startups. I hope all 8 startups succeed. No, I think it's fantastic, and taking that kind of integrated approach is actually an advantage for an early stage company where you can find shortcuts and you don't have to worry about the P&Ls of these 8 business units getting upset about each other. It's fantastic.
Yeah, I think that that's right. Yeah, that I mean, there is, you have a luxury of being able to constrain each of these problems. Um, and that's the only way that it's attainable, right? I mean, otherwise this would just be ridiculously foolish. And by constraining them and by making sure that they really are responsible for integrating with one another, I feel we've got a shot, but it's still a long shot.
Yeah.
It's hard.
Well, I'm definitely rooting for you. Brian, thank you so much. This is always incredibly fun talking with you. Thanks a lot for your time.
Oh, Ben, thank you so much. It's great to speak with you.